Hi guys, this is Mrs. Barenborg trying to record your lesson that has gotten so bumpy. I apologize. This is my third attempt at doing it, so I'm really good at this lesson right now, seeing that I've said it so many times. Okay, I'm going to start with opening up my presentation and showing you guys a little bit of what you missed the other day. Maybe you caught most of this, hopefully. Sometimes I just want to start over again, so that way you get it all. Okay, so fast forward if you need to. All right, so those were the items that I had to have you have before class. Make sure you watch that video because it's a really cool video, okay? And I'll put it up again in class for you. All right, this week is all about the spheres of the Earth, all the round things that we're going to talk about, the geosphere, the biosphere, the hydrosphere, the lithosphere, all those wonderful spheres. And Science Source covers it well from page 158 to 159 and 198 to 199. So those 4 pages, you're going to learn a little bit about these spheres. And we're going to start with the atmosphere. So the atmosphere is a mixture of gases that surround the Earth, and this protects us. So those gases are spinning very quickly, which creates friction. So anything that comes into those gases is going to hopefully burn all the way up. Okay, and we know that because we talked about meteors and meteorites last week. So the gases allow us to breathe on the Earth, but they also provide us with protection from UV rays from the sun, and they warm our planet, and they keep in the warmth with cloud cover, and that's called the greenhouse effect, and we've talked about that too. That it helps prevent extreme differences between day and night. So places that don't have a lot of clouds, like deserts, have extreme differences between day and night because the cloud cover is what keeps in heat. So let's talk about these atmospheric layers. So the first layer is called the troposphere. The troposphere is the one that's closest to the Earth's crust, and it's for the first 7 miles that you go up. So these lines shouldn't be perfectly in line like this, but that's the way this poster is that I got to use. So just know that it's a little bit off as far as the miles are correct, but the lines it's not exactly even like that. Okay, so the troposphere is the first 7 miles. And in the troposphere, you find planes fly, hot air balloons fly, helicopters fly, birds fly. All the life that flies and is walking on the Earth is in the troposphere. So we're in the troposphere because we walk on the Earth and we breathe the air. So the troposphere has the oxygen that we breathe. That's called O2, okay? Above it, and this is where most of the clouds fly too. Some clouds fly right here in the very bottom of the stratosphere. So that's the next layer that goes up to 25 miles high. And the stratosphere is where you can see weather balloons flying. And like I said, the highest level clouds fly there. And there's less oxygen, but now you get something called O3 up there, and that's called ozone. So you know how we had one atom of oxygen, and we learned in the fall about atoms. So we have 1 atom of oxygen. If you have 2 atoms of oxygen that bind together, that's called O2. If you have 3 that chain together, that is called O3 or ozone. And ozone is a protective layer right here that protects us from UV rays. And those are harmful rays that come from the sun. So the ozone, though, is getting holes punctured. And it used to be, a nice little gentle protection layer, but it's getting holes punched in it because of greenhouse effect gases. So carbon dioxide and nitrogen are affecting those ozone binds, and they're unbinding. And so that's kind of dangerous for us because it's allowing more UV light in to our atmosphere, and we can get burned up faster on our skin. But not to worry, ozone is still there. It's not all disappeared. Above it is the mesosphere. So that goes up to 50 miles high. And the mesosphere is where you can see your lovely shooting stars, which we now know are meteors, right? So when rocks come into our atmosphere and they're coming into this circling air, they get burned up as they come through the exosphere and thermosphere. And then you start to see the light in the mesosphere. So when you see shooting stars up there, which we know are meteors, you're actually looking into the mesosphere. All right, that's where most of them burn up. Some of them get to the stratosphere, and some of them we know get all the way down to the troposphere and land on the Earth, and those are called meteorites. But most of them burn up in the mesosphere. So above that is the thermosphere, and that's a warm layer. Over here are your temperatures. So the thermosphere is a very warm layer of circling air that's going around, and there's less air and less oxygen up here. That's why planes don't fly that high, because there's not enough oxygen to run the gas, run the engines, so they have to fly in the troposphere. But rockets can go all the way up here, okay, because rockets can refuel themselves. They don't need the oxygen from the air to reburn. So they go all the way up into space, and it takes them, 15, 20 minutes to get just to there. And they're going up 1,865 miles to get to space. So the last one is the exosphere, which is the last little bit of our atmosphere, and it's where we have satellites that are circling the Earth, and space station is circling the Earth there. So the exosphere is the outer atmosphere of our atmospheric layer. All right, the next sphere we're going to talk about is the geosphere. Geo means Earth. Geosphere is the solid parts of the Earth. So that's the continental crust and the oceanic crust. What is that? Land that we walk on, land that's under the ocean. Okay, so all of the land on Earth is called the geosphere, and it includes rocks, sediments, soil, landforms, and the processes that shape it. So, for example, lava flows, landslides, earthquakes, volcanoes, that's all part of the geosphere. And so the geosphere includes plate tectonics. So the plates that are moving underneath this rock cause it to change, ever change, and that is known as the geosphere. So these are three terms that you need to know that go along with the geosphere: weathering, erosion, and deposition. So let me explain the difference between them. Weathering is when rock wears down. It gets bigger and then it gets smaller. How does it get smaller? Lots of different ways. But rocks that bump into each other can break apart, like asteroids breaking apart become meteorites. Same thing on Earth. Big boulders will break down into little tiny rocks, and eventually they'll become soil. So rocks will merge with nutrients like dead leaves and animals that die and plants that die. All that stuff becomes nutrients in the ground. Remember, carbon goes back down into the ground and nitrogen, and it refurbishes the soil to make it really rich. And that wearing down is important, because rock then will become soil. It gets mixed with all those nutrients, and that's how it becomes soil. So wearing down is called weathering, and you can remember that because they both start with W. So wearing down, weathering, and that means a rock is actually just broken apart or worn down, made smaller. Erosion goes with weathering. So erosion is when the rock is carried away. What do I mean by that? The rock is actually moved. So when a rock is, or even land, is moved away from where it first was, that's called erosion. So a lot of people get these mixed up. They look at something that's being worn down and they call it erosion. That's not true. So for example, let me give you a good example of these two words. When water goes up on the beach and it's digging at the beach sand and it's pulling it away, the beach sand that has been scarred shows signs of weathering, right? It got worn down. The beach sand that's moving out to the ocean is called erosion. It's getting carried away. Okay, so the beach sand that's moving is eroding. The beach sand that just got knocked down is called weathering. Okay, those are the difference between the two words. Then deposition is the third one. The way to remember deposition is it deposits land on something. So all of these boulders falling down this mountain will end up at the ground, right? And they'll all pile up on top of each other. When they do that, that's called deposition. Same thing happens, and go back to the beach that I was talking about. When there's a bad storm, the water will push the sand from the beach up onto the land. That pushing of sand up onto the land is also called deposition. So deposition means depositing land or soil up on something else. Okay, so these three words go with geosphere. So we need the rock in a container and some water. And I'm going to show you really quickly how you can get weathering and erosion. So let me bring up my camera, and I'm going to bring up some water, and I'll show you here what happens. So I have some rocks that I've already done this with, because like I said, I've tried this lesson a couple of times. So you already can see evidence of these rocks breaking down, right? You see the sediment at the bottom. Sediment is actually just the piece of rock that's broken off. That's called sediment. So I have another one. I have a sedimentary rock. There are three types of rocks in the world: igneous, metamorphic, and sedimentary. Sedimentary rocks break apart easily because they've kind of just been glued together, either sand or little animals that die, and they get kind of glued together and compacted. So if this was to break something, it would break apart. You see all that came off right there? All that came off. That used to be the rock. If I put it in water, you can see it's bubbling, because that's probably limestone. So that bubbling shows that it's now starting to interact with the water, and the water will eventually break that rock down too. Water rushing over it will weather it, okay? And then the sediment will get carried away, and that's erosion, right? So weathering is when the rock gets broken. Erosion is when it gets taken away. All right, so let me go back to my presentation and just show you a little bit about, there we go, types of weathering. So you have lots of different types of weathering. Like I just showed you, you can get weathering from water. Water can break down rocks, like rain. Also, water can get inside of rocks, and then when it freezes, it can expand the crack in the rock and break the rock in two. All right, we see that a lot if you live up north, and after a really good freeze and then it thaws, you'll start to see cracks in rocks. You see that in the asphalt. When you drive up north on the roads are really rough, especially after a really bad winter, because they've been cracked by weathering. Okay, so they have to retar the road sometimes. Wind will cause weathering. That'll wear down this rock, especially if it's a really sandy rock. Wind will wear it down. Animals can break rocks, and people obviously can break rocks, right? We do construction all the time and break rocks. And snow can break rocks because of the freeze. The other thing that's kind of interesting is how powerful a seed is. If a seed gets into a crack of a rock, it actually can break a rock in two. And you can see evidence of that when you walk down a sidewalk. When you walk down a sidewalk, it's not always flat, is it? Sometimes you see the sidewalk is bulged, and it's bulged because of a root of a tree. So that tree root actually pushed up on the rock, and it will break the rock, because a plant seed is one of the strongest things on earth. I don't know if you knew that. Chemicals will also break rocks. So acid rain falling down, which is polluted rain, will fall down and actually tear down rocks or weather rocks. So that's all examples of weathering. Let's move on to the next sphere, and that is the hydrosphere. We're going to talk more about this sphere next week, but I wanted to introduce it because it's a sphere. The sphere, hydro means water, so that's an easy one to remember, hydrosphere. It means all the water on Earth, that's all it means. So you've got oceans, lakes, rivers, and ponds, all make up the hydrosphere. So whenever you're talking about hydrosphere, you're talking about all the water on Earth. And the last sphere that I'm going to mention is called the lithosphere. Lithosphere just means this outer crust and a little bit of the mantle right here, the orange part. So here are the layers of the Earth. You got the inner core, the outer core, the mantle, and the crust. We live up on the crust, and in the mantle's liquid. So this liquid is liquid rock. It's all molten hot. On top of it is this hard rock that's kind of slipping on top of this liquid rock, okay? And because of that, we get plate tectonics, and we get mountains being created, and earthquakes and volcanoes and all kinds of cool stuff. So if you like earthquakes, volcanoes, mountains, you want to study the lithosphere. The lithosphere is very interesting when you're looking at the crust and the mantle together, because that's when you get cracks and vents and geysers and volcanoes and earthquakes and really interesting stuff. So geologists study the lithosphere. Well, let's talk about this one. This is the one we're going to concentrate on today. This is called the biosphere. Bio means life, and this is the life it's a supporting layer of the Earth's surface. What does that mean? Well, from the troposphere all the way down to the deepest vents of the ocean, you get life. So you have life that lives way down deep in the ocean, and you have animals and plants that live in the air, right? You have tall trees, you have birds. So all of those things from all the way to the troposphere down to the deepest part of the ocean include the biosphere. But the biosphere doesn't just include life forms. It also includes the things that life forms need to live. So we have two terms, of course, more vocabulary in science. The first term is biotic. That means living organism. And abiotic is a non-living factor that has to do with helping these organisms live. For example, rocks, right? Rocks, soil, gas, I told you all those things. We need air to breathe. We need soil to grow things and provide us with food, right? And rocks break down into soil. So all of these non-living things help living things to live. And that all together is called the biosphere. Well, the biosphere includes biomes. And biomes are large areas of land and water, or land or water. So they can be split apart, or they include the water. And they're classified based on their climate and the salt level of the water. So, and all the plants and animals that live there have been adapted to live there. So for example, you're not going to see animals that live in the desert also be able to live way up high on a mountain. They just can't happen because they're adapted for hot weather. They can't live in this cold climate, okay, and vice versa. So what are biomes? There are two major types of biomes. There are terrestrial biomes and aquatic biomes. Terrestrial biomes are areas of land with similar climate that includes similar communities of plants and animals. So that includes land. So when we're talking about terrestrial biomes, we're talking about just land biomes. And they might include some lakes and rivers and streams, but mostly land. Aquatic biomes are mostly water. So you've got 3 different types depending on the amount of salt that's in the water. And that's how we determine what type of biome it is, by the amount of salt in the water. And also different plants and animals can only stand so much salt. So you're going to see whales living with a lot of salt, but they can't live in freshwater, and vice versa. You can't have freshwater trout living in the ocean. They just don't live there because they're not adapted for that. So let's take a look at that with our biome sheets. So I'm going to stop that, and I'm going to bring up my camera again, and I'm going to bring up my biome sheets so we can take a look at those. Okay, so these were the different sheets that I uploaded in the classroom, and I uploaded them again today so you'd have them. Excuse me. All right. So again, on this sheet, I sent you all the answers, so you should have them. Biome means life, and biomes are very large ecosystems. So we talked about ecosystems and we talked about habitats. These are bigger. They are big areas of land or water that are similar in climate or salt, and they have the plants and animals that have adapted to that area. Okay, they have similar precipitation. So in other words, the same amount of rainfall falls in that same biome. Either it gets a lot of rain or a little rain, or even amounts of rain, normal rainfall. And its temperature is even. So it's either a hot place or a cold place or a warm place. And the elevation is similar for that biome. So in other words, it's in the mountains or it's flat area. Okay. There are 3 aquatic biomes. There's a saltwater biome known as marine. So whenever you talk about saltwater, like saltwater animals, they're called marine animals. So if you've ever seen that term and wonder what the heck they're talking about, marine means saltwater. So when you see like a marine fishing area or marine boats, that means they go in saltwater. The opposite of that is freshwater. Freshwater has little to no salt. And freshwater biome is totally different than the saltwater biome. They don't exist together. Okay, they're totally different. The one that's in between those two is called brackish. And brackish water has some salt in it. Not a lot less than this, but a lot more than this. Okay, and that's called brackish. So brackish water you find a lot in lagoons that are close to oceans, and inside lands. So good example of that is kind of where I live. On the east coast of Florida, we have the Atlantic Ocean, then we have some barrier islands, and then next to the barrier islands, we have the lagoon, and then next to the lagoon, we have land, Florida. So just off Florida is this lagoon, and the lagoon has brackish water. Well, in between the barrier islands, there are little outlets to get to the ocean. Well, what happens is animals come into those outlets, like sharks. They will come into the lagoon, they will have their babies, and then they'll go back out into the saltwater. Okay, so the brackish water is really kind of a nesting area, or we call it the nursery of the ocean. Kind of interesting. Okay, so terrestrial biomes, I'm going to go into detail. There are 9 big ones, at least 9, because some other people have thought of some others, but I'm going to tell you the 9 that are accepted to teach. And those are the 9 I'm going to show you. They're not located on every single continent, but they're also not located just on one continent either. So they're spread out in the world depending on how much sunlight and heat is on that place in the world, right? And the elevation. So you can have a lot of sunlight, but if you're high in the mountains, you're going to still get cool weather. Okay, so there are 7 continents. And the last thing I have on here is the equator, because that's important. It's that imaginary line that goes around the middle of the earth. And that's what gives us the idea of where the sun is the most and the heat is the most in the world. And so because the sun is the most and the heat is the most in the world, the equator, around the equator is what you get, where you get the hottest biomes. So I am going to send you this sheet of answers, but I'm going to use it to talk about this sheet, which is the map. Okay, so I'm going to go through this map again for the 4th time, and I'm going to show you and talk about each of the biomes. So let me start up here by showing you the key. Okay, so on the key, I have dark blue. I made the polar region. So what you can do with the recording, which is the benefit of recording, is you can stop it when you need to make all your colors and then start it again when you want to hear me talk about the next part. Okay, so the first part I'm going to talk about is the polar region. The polar region includes the polar ice cap and the polar ice sheets. So the ice cap is over the land and the polar sheets are over water. All right, so the polar sheets you would probably describe as icebergs. And over the land, you would have glaciers, but you'd also have a frozen, packed ice frozen area right here. And this is called the polar ice cap. Okay, so you have these polar ice sheets and polar ice cap, and they're located in the northern hemisphere, way up here. They're also located in the southern hemisphere at the bottom of the tundra right here. So you got a polar ice cap down here in the tundra. And you have polar ice sheets in the water next to Antarctica. Okay, so Antarctica has a polar ice cap, but most of Antarctica is the tundra. That's the next one. So let me talk about the polar ice sheets. Polar ice sheets are, because they're totally covered in ice, you don't really see the land. And that's because there's so little sunlight that hits that part of the earth, right? And we looked at the tilt of the earth. When the earth is tilted towards the sun, this is getting very little sunlight down here. When it's tilted away from the sun, or even if it's tilted towards the sun and when it's hitting the Tropic of Capricorn right down here, you're getting a little bit of sun, but not very much compared to up here. This is where most of the sunlight's hitting. As a matter of fact, let me talk about that. Okay, but before I do that, let me just say one other thing. There's a fun fact that Antarctica down here, all this is frozen with ice. That ice is all fresh water, and 90% of the Earth's fresh water is frozen right here in Antarctica. 10% of it is out here for us, and a little bit of that 10% is drinkable, and that's the water that we use to drink. But all the rest of it here in Antarctica. So if you're running out of drinkable water, go on down to Antarctica. You'll find lots of it in the ice. Okay, so let me talk about these 3 lines here before I go further. I drew the equator and the Tropic of Cancer and the Tropic of Capricorn here for a reason. Now notice they're not straight across, they're a little bit curved. And the reason why is because of the tilt of the earth, right? The earth is tilted. And so because of its tilt, we have these 3 imaginary lines This one is 23 degrees north, right? 23 degrees north. And this one is 23 degrees south. Well, that 23 degrees should sound familiar because that's the tilt of the Earth, 23 degrees. What does that mean? Well, the reason why we have the Tropic of Cancer, and by the way, the reason why they're called Tropic of Cancer and Tropic of Capricorn is because when it's tilted over here in the summer, this line is right above the constellation Cancer that's in the sky. If you looked up, you'd see the constellation Cancer right over it. This one, when the sun is over it and the sun goes down and you look up, you will see the Tropic of Capricorn. You'll see the Capricorn constellation in the sky. That's why they're named that. Okay, so let's talk about this area here. When the sun is directly over the Tropic of Cancer, that is June 22nd, 23rd. That is when the sunlight is hitting this area the most in the world. So this is when it's the hottest here, is in June. Okay. Then the Earth goes around the sun and it gets hit down here when it's on the other side of the sun. And now the sunlight is hitting the Tropic of Capricorn. This happens during December 20th and 21st. So in December, most of the sunlight's hitting here on the Earth and little of it's hitting up here. That's why it's so cold in the winter up here. Okay, which is what we're experiencing right now. So that's why these lines are here. But in between these lines where the equator is located right here all the way around is the hottest spot of the Earth. And the reason why is because it's getting the most sunlight most of the time. And with sun comes heat. So all of the heat that is coming from the sun all the time is situated in this area. So you're not going to see any tundra here. You're not going to see any polar ice caps here. You're not going to see any taiga here because those are cooler areas. Even in the mountains, you're not going to see those, okay? Because they don't get cold enough even up in the mountains of these countries. So let's go back. We are now on to the second part, which is tundra, T-U-N-D-R-A. And the tundra, I did light blue. The tundra is located here. So this is the tundra all the way down to the top of Canada, top of Iceland and Greenland. And then over here on the top of Asia, which is Siberia, okay, which is close to USSR. So Siberia, or Russia, I should say now. So Siberia is in the tundra. What does that mean? What is the tundra like? Well, the tundra is very cold, not as cold as the polar ice caps, but it's pretty cold. And in the tundra, you have permafrost. So what does that mean? The land is permanently frozen. Now under here, you can't find the land, but here you can find the land, you just can't dig into it very well. So who lives there? You've got polar bears, fish, shrubs, and some polar bears will come up into the polar region too, but no trees. So you don't have any trees here and here. All up in the top of the world, there are no trees, only shrubs. And then way down here, the tundra is also covering Antarctica. Okay. So the tundra is known for barren areas. In other words, not very much life. So you got some fish, you've got penguins that live down here, right? Polar bears live up here. So those animals don't really interact because they live on opposite sides of the poles. So I love that. And the holidays, when you see a polar bear, a cartoon of a polar bear talking to a penguin. No, that would never happen except for the zoo, and I don't think they know how to talk to each other. Okay, so with that, let's go to the next one. The next one is the taiga, T-A-I-G-A, and I did mine in purple, okay? The taiga is located here. So you've got it at the bottom of Canada, bottom of Greenland, bottom of Iceland, bottom of Greenland, and you've got it all over Sweden, Norway, top of Europe, and all over the top of Asia. That's all the taiga. You do not see the taiga in the South Pole. And the reason why is because there's not enough land down here where it would get cold enough for the taiga, right here. Because this part, remember, receives more sunlight when we're closer to the sun. So this is not going to get as cold during the year as this is up here, okay? Because this receives less sunlight. So the taiga is an interesting biome. taiga is where you have coniferous forests. So you have cone-bearing trees. The reason why you don't have a lot of other trees is because the soil is not very fertile. And what I mean by fertile is that it doesn't allow things to grow in it very easily. Why? Because there are no leaves on the tree. There are only needles. And so those needles, when they fall, they cover the ground, but they don't break down very fast. Leaves, on the other hand, break down and they return all the nutrients back to the soil, along with animals that die, and all that gets turned back in, puts carbon and nitrogen back into the soil and makes it very rich again so that things can grow. Where the taiga, things can't grow very well because it's still pretty cold land and it's very swampy land, but you only see fir trees there. Okay, so you see spruce trees, you see moose that live there, rabbits that live there, those kind of animals, but you don't see any other trees. So that's mostly pine trees. So whenever if you've ever gone to the top of Canada or around the middle of Canada and up here, you will see lots of fir trees, and that's all you'll see pretty much. All right, the next one down is called, oh, and by the way, the taiga is also known as the boreal forest, Borreal, boreal forest. That's what some people call it, but it's taiga is what's accepted name. Okay, the next one down is called the temperate forest, otherwise known as the deciduous forest. What does that mean? Temperate means cool. So cool temperature forest, that's what it means. Not cold, cool. In other words, it warms up in the summer. The other thing you'll see in here are trees that change color, and those trees that change color are called deciduous trees. So that's why they call it the deciduous forest sometimes. So you'll see that the temperate forest here in North America, so southern part of Canada and most of the United States is temperate forest. You'll also see a little bit of temperate forest right here in South America, just at the Tropic of Capricorn, just below it. And you'll also see some temperate forest here in Europe and right here in southern Norway and Sweden. And you'll see temperate forest throughout Scandinavian countries right here and over here on Eastern Europe and China and part of Asia right here. I'm sorry, not Eastern Europe, Eastern Asia. And you'll see it all the way down to here. Okay, these are all temperate forests. And what does that mean? Those are changing leaf trees. So you'll see lots of different cool leaf colors in the fall. You'll see cool temperatures and you'll see warm temperatures, but you won't see extreme hot and cold. And you'll see a variety of plants and animals and that live in those, like bear, deer, squirrels, things like that. Okay, and then you have a little bit of temperate forest here in Australia, okay, and Tasmania and New Zealand will have some temperate forest. So temperate forest is kind of scattered all through the world. It's kind of interesting. That's the one you can find on almost every continent. All right, let's take a look at the next one. Rainforest. Rainforest is dark green. So the rainforest you won't find in North America, but you will find it in Central America, right here. And you'll find it mostly in South America, right here, because of the tilt of the earth. This one's going to receive a lot of rain and a lot of heat. And that's what you need for a rainforest. So you've got the rainforest here and here and here around the corner of Africa, underneath the Horn of Africa. You'll see this rainforest area right here. And then, of course, there's a little bit of rainforest over here on the northern part of Australia and all of these islands, Indonesian islands, South Vietnam, southern part of Asia. You'll see a lot of rainforest in here, which is beautiful tropical area. That's what you think of when you think of the rainforest, tropics. Well, that's because it's very wet, it's very warm, and it rains almost every day. Okay, so you have most animals live there, and the most diverse animal population live in the rainforest. So that's why we got to protect our rainforests and make sure that they stay where they are, because that's where you see monkeys, lizards, frogs, chimps, snakes, all kinds of different cool animals live there. Anaconda snakes, those big ones, live down here in the Amazon, right here. All right, so that's the rainforest. Let's move on. So our next couple of items in our key are the grasslands, and the grasslands are a light orange. So let's go here. We'll start over on the western side in North America. The middle of the United States is known as the grasslands area. Okay, that's known as the prairie. We talk about the prairie, same thing. The grasslands and the savanna are close, but they're not the same thing. Grasslands can be very, very cold in the winter and very, very hot in the summer. Okay, you have high grasses that grow here and wildflowers, snakes, mice, prairie dogs, things like that. So the grasslands is very big in the North America, in the middle of the United States. And then you have a little spot right here in South America, down by Brazil. And then you have the biggest grassland area in Asia, almost covering a lot of Asia right here, a lot of China. And then down here, southern part of Spain is grassland. And you have some grassland right here and here of Australia, two different spots on either side of the Tropic of Capricorn. Okay. So the grassland area is very diverse as far as being all over the map as well. The next one is the desert. So the desert's quite interesting. Oh, I'm sorry, the savannas. Savannas I drew in orange. So let's look at the savannas. That's very similar to the grasslands, but different. There are no savannas in the North America, none in Central America. You've got to get down here to South America to be able to see savannas. So this right here is the savannas. It's on the edge right here of Brazil. And you also see the biggest part is right here in Africa. This is savannas. You have some in the southern part of India, and you have some over here in the northern part of Australia. So what are the savannas? And I'll leave it at Africa because that's known for the savannas, how big it is. It's big, open, wide areas that really only have two seasons, wet and dry. They don't really change the leaves because there are very few trees, a lot of grasses, and the grasses grow big and tall during wet season, but then during dry season, they die out and they become very yellow. And there are open spaces where you have a lot of animals that graze and look for water. So in the wet season, there's water everywhere. It's called the monsoon season. And then in the dry season, they're looking for whatever water they can find, watering holes. And those animals would be in big herds like elephants, hippos, giraffes, lions. Oh my. So lots of big animals that travel around the savannas are located here, gorillas, and things like that. Okay. Very cool to see the savannas. All right, and the next one is the desert, and the desert I did in brown. So the desert is located in several different continents. So the desert is in Southwest United States, going all the way down through Mexico. That's all desert area right here. The desert is also this part of South America, all the way down to the Horn of South America, right here. The desert is at the bottom of Africa, and again at the north part and eastern part of Africa, like right here and here and here. This is all desert right here. Okay. The Middle East is all desert. That's a huge desert right there. Sahara is there, Gobi. Then you have this area right here on the northern part of India. It's also desert land. And then one more desert land right here in Australia, on the western part of Australia, and in the middle called the outback. That's also desert. So what makes it desert? The desert is the driest biome. And again, it's not the tundra. I know people thought the tundra was desert. I'm sorry, not the Antarctica. They thought Antarctica was desert. It's not. Desert is hot. Antarctica is cold. So why do people think this is desert? It's desert-like. What does that mean? The tundra is desert-like. They're both dry. Even though this has a lot of ice, It's dry because it doesn't rain. Same thing here with the desert. Doesn't rain. So let's talk about this big desert here, right? So you can go weeks without any rain. That's why you don't see very much vegetation there. And you see animals that wander. They're wandering looking for water, like camels who can retain water in their humps for a long, long time. And they can sustain that really, really high heat. And they can keep going till they find water. Same thing with cactus. Cactus can retain water inside them and have long, shallow roots to get whatever rain finally lands on the ground that they can take up and soak up. Okay, so the desert also is rare to see vegetation because it's very hot during the day, but it's also very cold at night. And that's because there's not a lot of cloud cover in the desert. So that's why it doesn't retain the heat. So at night it becomes very, very cold. And there are cactus that live there, snakes that live there, lizards that live there, scorpions that live there, all kinds of interesting, lovely animals. If you like those kind of animals, that's what lives there. All right, and the last one is the smallest area of biome on the earth, and that's the chaparral. And a lot of times that gets overlooked. As a matter of fact, when I was creating this sheet for you, I forgot to put the chaparral in, so I wrote it at the bottom of the sheet, okay? So what is the chaparral? Let's look. The chaparral is this red area. So you see the chaparral on the west coast of California, right here, the west coast of the United States. If you drive down the Pacific Coast Highway, you will see the chaparral right there. The chaparral is also located on the Horn of Africa, down here, South Africa. You will also see the chaparral all the way around the Mediterranean, pretty much, right here, and then the top of Africa right here, Tangiers, Morocco area. That's all chaparral. And then you'll see a little bit of chaparral right here in Australia. So what does the chaparral mean? It is a dense, thick, shrubby area. So you don't see a lot of big trees, but you'll see some small evergreens. And they look like they've been really gnarled by the wind. So they look kind of scraggly and strange looking. And that's because this area is very dry and windy. And because it's dry and windy, you get animals that don't need a lot of water that live there, or they travel to get water and come back. So aardvarks, wallabies, rabbits, birds, they all live in this dry, warm climate called the chaparral. Okay, so that is my Earth biome page. I'm going to back that up so you can see it. I will send this, again, I'll attach it again so you have it, along with the terrestrial biome page that I was speaking off of, so you have that information as well. Okay, let me go back and do my ending piece, and then we'll be done with this, and hopefully you'll be all caught up. Okay. It's always great just talking to myself 4 times, but I'm going to send you some homework challenges. So you're going to get this one, which is Bottle Biology website. It's really cool. It's where I got those other lessons from, but actually I have the book and I've had it for many, many years. Can't even say, I think 30 years. So it's been around a long time. But you take this is a great website because it shows you how to take lots of 2-liter bottles and do lots of different cool things with them. So this is another one, like I showed you how to make a terrarium and aquarium before. This is a terrarium and aquarium that actually hangs. So you can do that too. But these are biomes. So if you want to make a biome in a bottle, go to that website. It's fun. I'm also going to send you this page on weathering, erosion, deposition. You can try that and see how well you do and send it to me and I'll send you the answers back. And then I'm also going to send you a field trip. So we're going to go on a field trip this week virtually. And I created a Google Earth field trip. And if you've never done a Google Earth field trip, they're kind of cool. You go to Google Earth and it takes you on a trip. It shows you way down and looks at the biome and then brings you back out into space. And then it travels around Earth and takes you to the next biome. So I'm going to take you on a biome field trip. All right, here's a summary. The Earth is made of several spheres that interact with each other, and the biomes are the plants and animals that have common characteristics for the environment they live in. And life on Earth exists all because of that sun, and all the spheres interact with each other. And hopefully this recording will finally work, and hopefully you guys will be able to see it and not be totally bored with me. All right, you guys have a great week, and I hope to see you on Sunday with my hotspot in case of emergency. I got on my phone. All right, take care. Bye, guys.